everyone, my name is Ko Hui Jing. So my part is talking about the question 1. 25 samples of size 50 are chosen from a plastic injection molding machine producing a small containers. So from the data here, table here, we can see that there is a sample of 25, the size of 50, and the number of non-conforming items, proportion non-conforming respectively. So I will show you how to construct a P chart by using a Microsoft Excel. Okay, so I copy all the data from the table just now. Okay, so this is the sum of the N, number of inspected items, and this is the sum of the NP, number of non-conforming items. So we need to calculate the control limit, lower control limit, and upper control limit to plot our P chart. The control limit, the formula is over at the right hand side here. So the control limit is also called as the bar P, equal to the total of NP divided by total of N. So it's equal to 0.072. I freeze the number over here because I want to drag down all the way down. Okay, so I freeze it. So drag all the way down to the number of 25, and this is our bar P, and we need to calculate the upper control limit is equal to the bar P plus 3 times SQRT square root of bar P times 1 minus bar P, close the bracket, divided by N and close the bracket. So this is our upper control limit. So drag all the way down, and the lower control limit is the same, is equal to bar P minus 3 times square root, open bracket, bar P times 1 minus bar P, close the bracket, and divided by N. N is over here, and close the bracket again. So this is our lower control limit. Our lower control limit is negative value. So we assume our lower control limit is equal to 0 since it is lower less than 0. Okay, so we equal to 0. So this is the data we need. So now we need to plot our graph. We select the column of P bar P upper control limit, and the new lower control limit is 0, and insert the line graph here. Okay, here we look at our graph. Okay, from the graph here we can see that the statistic is not in control, because at the sample of 18, the proportion non-conforming is 0.2, which is over the upper control limit 0.18. So we need to delete the sample of 18 to make sure that our statistic is in control. Okay, now we copy all the data we need and we paste in the new sheet. So since from the sample of 18, our P is equal to 0.2, which is over the upper control limit 0.18. So we delete the sample 18. Now all the data change. The N is equal to 1020, 200, and the NP is 80. The bar P also change. Lower control limit, upper control limit also change. So now we can select the P bar P and upper control limit, lower control limit to plot our new graph again. So okay, from the graph now we can see that our graph now is all between the upper control limit and lower control limit. So it shows that it is in control. Now we change the title here, is equal to revise P chart, and we add the axis title. This is the proportion non-conforming which is P, and the x-axis is the sample. Okay, so this is the final answer of our P chart that is in control. So next we'll talking about how to plot a NP chart by using a Microsoft Excel. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sifa Farah binti Muhammad Noor. So today I'm going to teach you guys how to do a control chart for attributes using Excel. But Excel is the most easiest one. But we can also use another else software. But so today, as we can see here, this is the question that I want to do it with you guys today. So we need to construct an NP chart for the number of dissatisfied customer. So this is the number of sample 20 and the number of size. The sample size is 300. So as you can see here, I already insert the data here. So basically, the first thing first that we need to do is we need to find the mean, because the mean is the value of mean is actually the same with the value of center line. That's why we need to find the value of mean. So this is the formula for mean. Sum of the data from sample 1 until sample 20. Then we divide it by the number of sample, which is 20. After that, we need to find the value of standard deviation. So the formula for standard deviation is square root of NP bar multiplied with 1 minus P bar. But first of all, we need to find the value for P bar first. So as we can see here, the center line value is equal to NP bar. So if we want to find the value for P bar, P bar, so we need to divide the mean by the number of the sample size. So this is the mean, and we log the value by pressing F4 and divide it by the sample size, which is 300. So after that, we already have the P bar value, right? So we can find the value of standard deviation, square root of NP bar. So NP bar here is the mean, right? So C1 and log the value. Then we multiply it by 1 minus P bar. So P bar, the value that we find just now. So then this is the value for standard deviation. So right now, we to plot a control chart, we need center line, upper control limit, and lower control limit. So for center line, as I mentioned before, is the same value as the mean, right? So we just take it, the value for mean, and log the value, and we take it is, so it's same for all 20 sample. So we take it until this. So it's like this. Alright, that is center line. So to find upper control limit, the formula is NP bar plus 3 standard the value of standard deviation. So NP bar is mean, right? So C1, log the value, F4. Then we plus the 3 multiply with the value of standard deviation, this one, and log the value. And this is the upper control limit. So it's the same for all sample. Alright. So lower control limit, we minus it. Just now we plus, right, 3. So the mean and log minus 3 multiply with the standard deviation and log it. Alright, this is the lower control limit. And we take it until here. Alright, that's all for the data. After that, we already have the things that we need to do a control chart. So I I small the picture because you already know the formula, right? So we want to do a control check for this data. So we go to insert and we choose the chart we want to do. So this is the chart. We delete it, the sample, because we don't want it in the graph. We just want to see the center line, upper control limit and lower control limit. So basically this is the input chart. So after that, as we can see, the yellow line is here is the control, the upper control limit at data level. This is the lower control limit, and this is the center line. So as we can see here right now, the control chart, we can see here there's a point that out of the limit, which is the sample at 12. So as we can see, our upper control limit is 18.15884, right? But the value for number of dissatisfied customer is 19. So that means our process is out of control because there one point that out of control. Maksudnya that means that is more than the upper control limit, right? So we need to delete the data, so we can make the process is in control. So as we can see here, this is the graph that I have done before. So as I said earlier, the number of sample 12 is number of dissatisfied customer is 90, right? So it's out of control. So we delete the sample at 12. So the sample of size still 300, but the number of sample become 19 because we already delete one sample. So as we can see from the chart here, is all the point is in control. So that's me. We already make sure that the process is in control. So that's all. I hope you understand what I'm teaching you guys. And thank you for lending your time to hear my explanation.
Hi everyone, my name is Nur Akranti Bahri, and today we'll take a look at question number 3 regarding C chart. So this is the data for 25 samples and number of non-conformities. So we'll solve it using Excel. So this is what we get after we transfer all the information, all the data in Excel. So how to calculate LCL, CL, and UCL in below. So CL equal to C bar, UCL equal to C bar plus 3 square root of C bar, LCL equal to C bar minus 3 square root of C bar. So after the calculation, we get C bar CL equal to 7.56. So we move to this 7.56, and we drag this. Okay. So that after that is UCL. So UCL we get is 15.809. So we transfer into the data. And we drag it. And also this one. After we calculate SL, we get negative 0.8 and 0.689. Negative 0.689. True. Okay, yes. So we drag it.
So after we get this, we get negative 0.689. So we assume new LCL is equal to 0. It is because LCL cannot be less than 0. So drag this so we can get. So after that, what we should do is we construct a graph. Okay. Select this all. So exclude this one. And okay, so this is the chart that we will get after insert all of the data. So as you can see, there is a data that above upper control limit. So we have to remediate all the data, and we exclude the sample number 9. So after that, we revise and we recalculate back all the CPA, LCL, and UCL. So this is what we get. Okay, and then we try to construct a graph. So we construct a graph, select all of this, and exclude this one because we don't want this. Okay, and insert graph. Okay, so the process is in control because there's no above upper limit and below lower control limit. Okay, so that's all. Thank you.
Hi, my name is Nurul Akila, and now let's continue to number 4. Okay, so this is the question for number 4, and now let's get to the Excel for number 4. Okay, so here's the amount inspected, the N, and number of conformities is C. So what we need to do first is need to get the values for U. So U here is the C divided by N. Okay, so we need to get all the values for the U for each sample. So we have 20 samples. All we need to do is drag them until the 20th sample, and then here you go. And then next, for the U bar, so U bar is the total of C divided by the total of N. So we need to find the total of C first, and equals sum. Okay, click on that and then drag it, and then we have the total of C, and then we need to find the total of N. Sum. Okay. Oh. Drag that and close bracket. Okay, now we have the total of C and N. We can now get the values of U bar. So U bar is C total of C divided by the total of N. So we got these values. So what we need to do now is to copy them. Copy these values. So the U bar is also the center limit. Okay, so we're done with the center limit. Now for the upper control limit. The upper control limit is the U bar plus 3 square root the U bar divides by N. Okay, and then drag this. So we're done for the upper control limit, and now for the lower control limit. The formula for lower control limit is quite similar to upper control limit, but we changed the plus sign to minus sign, subtraction sign. So the U bar, okay, minus 3 times square root of U bar divides by N. So you got the answer, then drag it. Okay, but as you can see at the lower control limit, there are negative values here, so we do not want these negative values. What we need to do is change them to 0. So change all of the negative values to 0. Okay, and then to 0, and then we're done. So just go to insert, and then the graph, and then oops, where's my graph? There's no graph. Oh, I forgot to drag, sorry. Okay, okay, here's my graph. Okay, the chart. So I'm gonna change it to new chart. Okay, so here's the number of samples and the number of conformities per unit. So as you can see, the lower control limit and the upper control limit are not in a straight line because we are dealing with proportions, and proportions vary in every group, so they are not straight lines in this case. And the next thing that we can see through this chart is we can see that this the sample number 7 is out of the control limit. So basically this chart is out of control. So what we need to do is we need to revise the chart. Okay, so we go to the next sheet to do the revised chart. Okay, so to do the revised chart, what we need to do is to eliminate the sample number 7 here, but in this case it's the number 8, so we delete this. Okay, delete. So we need to do redo the U bar. Okay, so because the total of non-conformities and the total amount of inspected have changed, so we need to redo the U bar. So U bar is the total of C divided by the total of N. So we get the U bar, and then just copy them. Alright, and then for the upper control limit, U bar plus 3 times square root u bar divided by 2. Okay, and then drag them. For lower control limit, and u bar minus 3 times square root u bar divides by 2. Okay, so that is the lower control limit, and we need to change the negative values to 0. Change the negative values to 0. Okay, and then do the graph. Okay, so here's the revised U chart, our revised U chart, and through this data plotted, we can see that this chart is in control. So we're done for the U chart. Thank you.
Hello, my name is Oh Sing Yi. I'm from Group F. I am responsible to solve the question number 5, which is the control chart for number of demerits per unit. I have copied the data here to here. And the first thing to solve this question is to calculate the total demerits for each sample. And the data, from the formula, we know that we have to multiply by the weightage for each of the C. And the weightage is 10, 50, 10, and 1 respectively. So here we can sum them up. And same things for the others. And after that, we calculate the demerits per unit. The formula for demerits per unit is here, divided by the number for in the sample, which in each sample we have 10 customers. So here we have to divide them by 10. After that, we solve the U1 bar. For U1, which is the formula is C1 multiplied by total, which is 20 multiplied by 10. Total is to be 200. And next thing, we solve this. The CL, the center line, we have to log them up because the data for each of the And then the next we calculate the UCL. From the notes here, we know that the UCL formula is the center line plus 3 standard deviation. Here, copy the value here. The variance is, the formula of variance is 50 square divided by multiplied by this one, and 10 square multiplied by. So now we got the value for standard deviation. The UCL, the value is this. 3. The lower center line is negative, and we can assume that, sorry, we can assume that the LCL is equal to 0. Now let me copy the value here. So now we can plot the data. Then we have to remove the LCL here, which is the -5 one. So our graph will be like this. That's it. This is our U chart for number of demerits per unit. Thank you.
So this part is going to show you how to plot a S chart and bar X chart by using R programming. So this is the data given in the first question. We have the sample of 20 and sample mean and sample deviation respectively. So now we open our R Studio, our R programming. Okay, we need to install the package QCC first. Okay, installing first. Now we need to run the library of QCC. We need to study the package. Okay, waiting for run. Okay, now the QCC library is study. Okay, before we do the X bar chart, we need to confirm that the S chart is in control. So we plot the S chart first. First, the standard deviation data is over here. The standard deviation data is 4.6 until the 5.4. We key in all the data here and then we run. Okay, after that, to find the S chart, we need to know the control limit, upper control limit and the lower control limit. So this is the formula over here. We need to find the bar S. Bar S is the mean of the standard deviation. So we need to find the mean of the standard deviation here first. Okay, run. The standard deviation of the mean is the 4.79. Okay, the upper control limit is equal to B4 times bar S. Okay, so B4 of the size of 4 is equal to 2.266 times bar S is mean of standard deviation. So we run again this row. Okay, we run again, the upper control limit will become 10.585. Okay, now we know our upper control limit. The lower control limit is equal to the B4 times bar S. So lower control limit equal to B4, our B3. B3 is equal to 0 times the bar S is mean standard deviation. So you run again this row and run again, the lower control limit will be 0. So now we know that our bar S is equal to 4.79, the upper control limit is 10.85 and the lower control limit is equal to 0. Now we know all the data we need and then we can plot our S chart now. So this is the how to call our S chart. Okay, we run this row. Okay, so the right hand side here shows the S chart that is in control, which is within the upper control limit and the lower control limit. So we shows that the S chart now is in control. We can do our X bar chart now. So our X bar chart from the data given is from the 36.4 until the 37.7. We copy all the data into the X bar. So we run this row. After that, we need to find the X bar chart. Okay, we need to know the double X and double bar X and the bar S. Bar S is we have found just now for the X bar chart. Okay, and the A tree. Firstly, we need to find the double X first. Double bar X. Double bar X is equal to the mean of the X bar. Okay, so we run. Our double bar X is equal to 37, and the upper control limit is equal to double bar X plus A3 times bar S. Okay, double bar X is here plus our A3 is equal to 1.628 times the bar S is here. We have run just now, so we will just tap over here, then run again the upper control limit. So we get our upper control limit is 44.97, and our lower control limit is equal to double bar X minus 1.628 times our bar S over here. So we run again, and we run the lower control limit is equal to 29.37. Okay, now we know all the data we need, which is the double bar X, the upper control limit, lower control limit, the data. So now we can run our X bar chart. So this is how to study the X bar chart. So we run. Okay, so this is the final X bar chart that we found from the R programming that is in control because it is between the upper control limit and the lower control limit. This part is going to show you how to plot a bar X and the range chart by using the R programming. Okay, so from the data here, we know that we have the sample of 25 and we have the value of bar X and R respectively. Okay, now from the R programming, same method with just now, we need to install the package of QCC and then we run the library of QCC. Okay, before we want to plot a X bar chart, we need to make sure that our R chart is in control. So let std is the value, here is the value of R chart, of the R. Okay, from the R here, we need to type all the R value into the std here. Okay, we run, and then we want to plot a R chart, we need to have the upper control limit, lower control limit, and the control limit. So this is the formula, and control limit is the bar R, and the upper control limit is the D4 times, actually this is bar R, and lower control limit is D3 times bar R. Okay, so our bar R is the mean of std. Okay, we run. So our bar R is 3.88. So upper control limit is D4. D4 is 2.114 times the bar R. Okay, so we write the formula first and then we run again. The upper control limit is 8.2. So the lower control limit is D3 times bar R equal to 0 times bar R. So we write the formula. So formula here, and then we run again. The lower control limit is equal to 0. Okay, now our upper control limit, our control limit, and lower control limit is found. So we can plot our R chart now. So this is how to write a R chart in the R programming. So from the R chart over here, we know that the sample at 13 and the sample 19 is an outliner which is over the upper control limit, so we need to delete the sample 13 and 19. So we find the 13 and 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13, 14, 15, 16, 17, 18, 19. Okay, so this is 19. So we cancel these two samples and then we do again the R chart. So we study again, run again the value here. Okay, and then we find the bar R. So bar R now is 3.3. Okay, now the upper control limit, and then run again. So our upper control limit now is 6.98, and then the lower control limit we run and then run again. The lower control limit still 0. Now we have our control limit, upper control limit, lower control limit, so we can find our R chart. So this is the how we write in the R programming to find the R chart. So this is the final R chart that is in control within the upper control limit and lower control limit. So now our R chart is in control, we can find our X bar chart. So this is the value for the X bar chart that delete the sample of number 13 and number 19. Okay, so we run the data of the X bar. Okay, we run already. Now we want to find the X bar chart. We want to find the upper control limit, lower control limit, and the control limit. So the formula will be double bar X and plus the A2 times bar R. Okay, so the double bar X is equal to the mean of X bar. Okay, so we run the mean of X bar is equal to 20 of 86. Now we want to find the upper control limit is equal to the double bar X plus A2 times bar R. So this is double X bar. So our A3 is equal to 0.577 times the bar R is equal to mean of standard deviation up here. So we run the upper control limit and run again. Upper control limit is equal to 22. Okay, now our lower control limit run and run again. The lower control limit is equal to 18.9895. So now we have the control limit, upper control limit, lower control limit, so we can plot our X bar chart now. So now we plot our X bar chart here. So this is the final X bar chart that is in control because it is between the upper control limit and lower control limit. So this is how to plot a R chart and X bar chart in R programming. Thank you very much.